Okay, another application of dynamic programming is in to solve this knapsack problem. Okay, so before that knapsack problem, there is another terms, okay, for knapsack problem. Okay, so they are the same. Sometimes people refer to it as a flyaway problem, or maybe a cargo loading problem. Okay, so for the knapsack problem, basically it deals with the situation where a soldier, okay, must decide on the most valuable items to carry in a backpack. So actually the same goes for flyaway kit and also the cargo loading. So for flyaway kit, so basically this problem related to a pilot, okay, a jet pilot, where during the emergency they have to determine the most valuable items, okay. So basically it's the same like knapsack problem. So we have to decide which one is the most valuable item to carry along, okay. So sama juga with the cargo loading. So in cargo loading, you have the vessel, and that vessel have the limited capacity or the limited limited volume. So you have to decide which is the most valuable items to put into the cargo. And this knapsack problem is also similar to a general resource allocation problem, where we have a single limited resource that will be assigned to a number of alternatives, where our objective is to maximize the total return. Here is an example of a knapsack problem. Okay, so we have a 4-ton vessel that can be loaded with one or more of 3 items. Okay, so these are the items that we have: item 1, item 2, and item 3. So in this table we are given the weight and also the return or the revenue for each item. Okay, so now the question is, how should the vessel be loaded to maximize the total return? Okay, so remember, this is the weight, W is the weight for each item, and R here is the revenue. Okay, W is the weight and R is the revenue or the return. So basically each item have their own weight, have their own return, okay, but the capacity for this vessel is only 4 tons. So now you have to come out with the solution how to maximize the total return. Okay, and before we proceed, please remember in dynamic programming there are 3 basic elements that you have to pay attention. Okay, so the first one is the stages. Remember, for dynamic programming you have one problem and we will split into several stages. Okay, that's the one of the basic element. And then for each stages you will have this alternative. Okay, and for every stage you also have the states. Okay, so these are the 3 basic elements that are very important that you have to identify for every problem in dynamic programming. You have to identify the stages. So in order to identify the stages, you have to find the relationship, okay, that bind the stages together. Means that when you broke or split the problem, okay, into several stages, what is the characteristic that bind the stages together? Okay, and also the alternative and also the state. So because in dynamic programming, remember, we solve or we find a feasible solution in one stage, okay, in every stage, and then we combine everything together. So that's why you must have a relationship that link every stage together. Okay, so before we proceed with knapsack problem, how to solve this, so I mentioned just now, we have to choose which item to be loaded into this vessel where we have limited capacity. It's only 4 ton, and for every item itself they have their own respective weight and they have their own returns. And in order to this, let's say you choose item number 1, how many units of item number 1 that we should load it into the vessel. So in this case, we need to introduce another variable. Let's say I put M here. So M here, or MI, M is the number of, let's put number of unit of item I. So for example, you choose item number 1. Okay, so let's say item number 1, and how many of item number 1? Okay, so if item number 1 you should 2, so M1 equals to 2. Okay, so M here refer to the number of units of item I. So in this example, basically, since we want to maximize the total return, so we can say that we want to maximize return, so we use R. So maximize R1, return number 1, times the number of unit for item 1, okay, plus return for item 2 times the number of unit of item 2, and plus return for item 3 times number of units for item 3. Okay, so if let's say you want to model it like the linear programming or integer programming that we have learned before. Okay, so basically we want to maximize, and this will be our objective function. Okay, and for the constraint, okay, subject to the constraint now is the limit. Okay, because we only have 4 ton here, so for each limit, each item they have their own weight. So subject to weight for item 1 times how many units of item 1 plus weight for item 2 times how many units for item 2, okay, and weight for item 3 times how many units of item 3. Okay, because in this case we only have 3 items, and all together must be less than 4. Okay, so back to our example. Remember the 3 basic elements in dynamic programming for the stage. Okay, so in this case we can take the item as the stage, means that in this case we have item 1, item 2 and item 3, so we can have stage 1, stage 2 and stage 3. Okay, now for the alternative, here, because alternative at stage 1 for example represented by M, okay, we can use M, okay, because M is the number of units of item I. Okay, so let's say for stage number 1, so stage 1 refer to item number 1, so how many units of item 1 that we should load or put into the knapsack. Okay, but in this case, since we are dealing with the vessel, okay, so how many item 1 that we should load into the vessel for stage number 1. For stage number 2, how many units of item 2 that we should load into the vessel. Okay, that is the alternative. Then for the state, we can use xi, where xi is the maybe I can put xi is the total weight, okay, assigned in to that stage. Okay, for example, in stage 1, so after we are using the alternative, so how many total weight in stage 1, then how many total weight in stage 2, and so on. So as a start, remember, it's better if you use the recursion, the backward recursion. So in that case, we have to start with item number 3. Okay, because item number 3 will be our stage 3. So for item number 3, for every unit, the weight is 1. Okay, and for this vessel, the total or the capacity is 4. So the maximum unit that we can put, the maximum unit of item 3 that we can put in this vessel is 4 divided by 1. Okay, 4 as the total capacity and 1 here as the weight for item number 3. Okay, so in this case, the maximum unit that we can put in the maximum unit of item 3 that we can put in the vessel is 4. So for M3, the possible values are 0, 1, 2, 3, or 4. Okay, so 0 here means you don't select item 3 at all. Okay, 1 here means that for overall capacity, you select 1 unit of item 3. Okay, same goes to M2 and value 2 and value 3. And the last one, M3 equals to 4, means that you put everything, all the items is referring to item number 3. Okay, so stages, third stage means that refer to the item, okay, item 1, item 2, item 3. So for the alternative, refer to this one, okay, how many units of item I that we should choose. And for the state, the total weight, so the total weight here, since the capacity is 4 ton, so the total weight will range from 0 until 4. Okay, so 0, 1, 2, 3, and 4. Okay, so x3 equals to 0, 1, 2, 3, and 4 represent the total weight. So M3 equals to 0, 1, 2, 3, and 4. This one come from here. Okay, so 4 here is the total capacity divided by 1. 1 here is the weight for every item. Okay, for item 3. And so you got 4, so M3 will be 0, 1, 2, 3, and 4. And now we are focusing at stage 3. So now put every details in a table like this. So for stage number 3, remember x3, okay, we have the total weight. Okay, the total weight range from 0 until 4. So 0, 1, 2, 3, and 4. And we also have alternative here. So remember, 4 divided by 1, you got 4. So you got M3 equals to 0, M3 equals to 1, M3 equals to 2, M3 equals to 3, and M3 equals to 4. So 14 M3 here, 14 here is the revenue for item 3. So that's why we have 14 M3. This is because if, let's say, our decision is to take 1 unit of M3. So 1 unit, so it will be 14 times 1. If we choose 3 units of item 3, so the revenue will be 14 times 3. Remember, because we want to maximize our returns. Okay, so that's why we put the objective here. And there is another condition. Okay, you have to make sure that this W3 or weight for item 3 times the alternative is less than equals to x3. This is to make sure that the combination here is always less than the total weight.